Guys, happy to be here. My name is Weizman. I'm gonna be talking about JavaScript realms, a blank spot in web application runtime security. I wanna lay out the talk for you first. So first, we're gonna talk about the evolution of the web, how we transition from websites to web applications, the way I see it. Then we're going to talk about the importance of security and visibility, specifically in the context of the evolution. We're going to talk about how third-party solutions help with security and visibility, what they solve, how they do it, and we're going to focus on what they miss. So, spoiler alert, what they miss is things that are related to JavaScript realms, which I find them to be the blank spot in the runtime application security. And then we're gonna end up talking about Snow.js, which is a interesting solution that we're working on for that problem, and I'm pretty sure it's the most interesting one out there. But before we begin, I'd like to introduce myself properly. So my name is Gal Weizman. I have been doing web and browser JavaScript security for I think around 10 years now. I started off doing that at 8200. And then I worked for a few startups. I think the most popular one of them was Perimeter X, which are also doing web browser JavaScript security related stuff. I also have some published work, so make sure to check that out. I published some CVEs in the context of security. Also a few interesting security techniques. And today I work for MetaMask, which is a crypto wallet, quite famous, which comes as a browser extension. And what I'm doing there is also JavaScript security stuff. As part of the job there, we're also working on Snow.js, which is the solution we're going to talk about later. And we can begin. So I'd like to lay out the evolution of the web the way I see it. So at the beginning, we had simple and static websites. And since they were simple and static, they were also very secure, and the visibility into what they were doing was quite clear for a number of reasons. So one of them is how the exposure to code was quite minor in terms of our development and...
Just a sec, we'll rehook the computer.
You can press join in the Zoom.
Yeah, no, it's okay.
Oh, all right.
We're good?
Yeah.
All right. So as I was saying, they were secure and visible for a number of reasons. So one of the reasons is how there was a minor exposure to external code. So back then, when you had like your cycles of development and deployment, they were very straightforward when you had like simple static websites. And therefore, the code that was responsible for processing the application when developing and deploying it was quite simple and straightforward. The frequency of changes to websites was very low. So because of how they were not that complex, you didn't really have to change them that frequently, which is also something that helps with visibility. And I think most importantly is how back then the dependency of third-party code was not really a thing. So supply chains, third-party services, stuff that we use today, they weren't that big of a thing back then. You usually just like build your website, rely on your own code. But then we transitioned to what we have today. We have complex and dynamic web applications in contrast to websites. And I say complex in a good way because we benefit a lot from that. We have automated development, build, and deployment processes, so we can basically just deploy code and develop it and build it with like using external tools, which help us do it automatically and quickly, which is a good thing. We can depend more on outsourced code, so we don't have to write everything ourselves every time we want to create a new web application. We can just rely on external code. And we can also consume third-party services within our web application to enhance what it has to offer. I think a good example for that is advertisement or payment third-party services that we usually include within the application, and it allows us to enhance what we have to offer in our application. So that's like a good thing. But there are also downsides to having complex and dynamic applications. And the most problematic part about it is how the security and the visibility level into your application is being shaken. Because now you are highly exposed to code that processes your application. As we said before, due to the development, build, and deployment. The frequency of changes the application goes through is way higher than before, which also might end up in higher security concerns. And that is due to the rapid development cycles we have, how we continually improving our application, how the expectations of the users of the application is there, and you always have to stand up for it. And also the fact that the application is complex and therefore you just have to continually update it. And most importantly, and that's what we're going to focus on today, is how the dependency on outsourced code is insanely higher. Like today you build your application usually relying on a supply chain of third-party packages and also third-party services. And that means that a big amount of the code that your application consumes is something that you were not responsible for and you perhaps have never seen before. And that is a problem in terms of visibility, but most importantly, in terms of security. So laying out that makes it important for us to talk about the importance of security and visibility and what those are exactly. So visibility refers to the ability to see into the inner workings of a system and understand what is happening within it. And that is something that is important, especially today, because you have so many reasons why you want to maintain a certain amount of visibility. You want to understand loggings and error handling that happens within your application. You want to be aware of the performance level and make sure that it didn't change. You want to make sure that the user experience is as good as it was before, even though you continuously change your application. And I think most importantly, you want to make sure that the level of security, it remains the same. And when your application changes so frequently and relies on so much third-party code, that's something that is hard to maintain. Yeah, so when you lack visibility, it's hard to keep the security of your application. And I think the most important part of this to understand is that today the attacker is inside the application rather than what it used to be. So let's pause here real quick. So back then, I think the number one vulnerability we were worried about in terms of our client-side application or website, you can call it, was, for example, XSS, which is a vulnerability that is outer to the application. And we are at a very interesting position today where we're worried about vulnerabilities that are within the application. So if someone manages to breach a third-party service that I consume or breach my supply chain, I might end up in a place where an attacker would be able to execute code from within the application and not from outside of it. And that is an important thing that really changes how we need to think about security in terms of web application. Which brings us to where we at today. So our applications are obviously still complex and dynamic, but the security and visibility level is higher this time. And that is thanks to third-party services. So here are just like a few examples of security vendors and visibility vendors that we now consume within our applications in order to address specifically the security and visibility problems. This is just like a few examples here. So third-party services came to the rescue, and they allow us to improve the visibility into our applications and to maintain a security level. And you have a lot of different approaches to achieve that. So there are a lot of solutions, for example, that use backend oriented solutions. You can take SNCC, for example, but we're not going to focus on those. We're going to focus on the type of solutions that you see on the screen right now that usually integrate a client-side based solution. So let's understand third-party solution. How exactly are they helping us gain visibility and improve our security? So by granting those third-party services control over our application in runtime, they are able to improve our security and visibility. So for example, in terms of security, one thing that you can achieve by granting those third-party services control in runtime is to monitor sensitive operations being made in the app and detect strange behavior. You can use those services to block the application from communicating with malicious entities, for example. And in terms of visibility, you have also a lot of interesting examples. So you can use those third-party services to map out what happens in your application. You can capture errors and logs. You can track the experience of the user and make sure that the level maintains. Same goes for performance. You can monitor the performance of your application. And I think it is important at this point to understand how exactly those third-party solutions work. So this is where it gets a bit technical. So first of all, you just include the third-party service in your application, usually as a third-party script. So it usually looks like that. You just consume it from like the third-party vendor. And then those services run JavaScript code that applies what is usually known as behavioral overriding and is also known as monkey patching. So here's a nice example for what monkey patching really is. So you can see here that, for example, if I want to override the behavior of the alert function to make sure that if anyone tries to alert the word Voldemort, I'm going to throw an error because that is a name that should not be named. So I can achieve that by simply overriding the real alert function to behave differently than what it was supposed to behave. And you can see down here that when I call the alert function on a string that does not contain the forbidden word, then the alert function would work. But if not, an error is being thrown. And that is a way that I can change the real behavior of a function in runtime. So this allows services to get full visibility and control into the application. So now that we understand what monkey patching is, it's important to understand in our specific context how they allow us to create third-party solutions for security and visibility. So let's give a few examples. So in terms of visibility, for example, you can use monkey patchings to hook into report to the reporting action of errors or messages and stuff like that. A real example for that would be LogRocket. So that's something that they actually do. And it looks a little bit like this. I do want us to understand this example because we are going to talk about it later on. So you can see here that we are overriding the console.log function to still log any message that it receives. But in addition to logging it, we are also asking our JavaScript function to pass that message and the time it was logged to the console to our very own log server vendor. So that's just like an example of like something that LogRocket and services that are similar to LogRocket do. And in terms of security, there are also interesting examples. So an example we're going to focus on today is the ability to defend sensitive information that is stored in the local storage. So for example, if I'd like to, a real example to that would be parameter X. That's something that they actually do. So for example, in this example, you can see that I override the behavior of the get item function of the local storage. And by doing that, I can ask the function to give away any key in the local storage except for the secret item. This is obviously a very simplified example, but it's just an example of how I can use behavioral overriding to change how the application works and make sure that no one has access to secret items in the local storage. And you can see in the example that when you try to get an item that is not a secret item, you get its value, but you're not going to get the value of the secret item. Now, this is the interesting part. So we're going to try to understand here what the problem with those solutions are. So most of the solutions are missing something important, and that affects mostly security, in my opinion. They're all lacking visibility into JavaScript realms. But before we understand how, I think it's important that we go through what a realm is real quick. So a realm is an interesting concept. I learned that I was not well aware of what it is exactly. So as part of my research, I also created, I posted a blog post talking about that. So you can also check it out if you want to understand realms more, but I'm gonna give you the short version. So you can informally think of a realm as basically an ecosystem in which a JavaScript program lives. And just like any other ecosystem, it includes different elements that JavaScript programs must have in order to exist within. So some examples are,
Just disconnect and connect.
sorry about that. Okay. So some examples for things you get as part of having like a JavaScript realm is a global execution environment. So each realm has its own distinct global execution environment. As part of that environment, you get a global object. And that global object grants you access to different intrinsic objects or APIs. So you know them as like array, object, function, stuff that are built in the JavaScript language. But you also get access to platform-based objects. So you have access to the document, you have access to the fetch API, and there are other examples as well. But like this is like the gist of like what is the difference between realms. So a realm, as I said, is a JavaScript concept, but its implementation in the browser introduces more aspects to be aware of. So let's talk about that real quick. So in the browser, you can access the global object of the realm as window. And by default, a web app only have one single realm, which is the top main realm. And you can also access it using the top property. And you can create child realms in your top main realm, and those realms will be same origin by default. So same origin realms are two realms that can dynamically access each other and manipulate each other based on the fact that they are relates to the same origin. So you can achieve same origin realms in a few ways. You can create an iframe, a frame element, object element, embed. You can also use the open API, which allows you to open a new tab, and that tab would also be in the same origin unless you change it to a different origin. But you can also have a cross-origin realm, and that would be achieved by redirecting the new realm that you created to a region that is different than the origin of the creating realm. And you don't get the synchronous access between two realms that are cross-origin, and that is due to security. So a cross-origin realm can also be formed as a web or a service worker. So service workers and web workers, they have their own they have their own realms, and those realms are by definition cross-origin to all other realms in the application. This is just like a very simple example of how you can think of realms in terms of like HTML structure. So why do I think that realms are kind of a blank spot when it comes to third-party services in the client side? So there are two main reasons, and we're going to focus on these two. The first reason is how realms can go under the radar of third-party services behavioral overrides. And the second one is that realms can affect the top main realm without being caught by the third-party services behavioral overrides. Now we're going to examine these two examples to make sure that we understand them properly. So let's talk about the first one. The fact that a realm can go under the radar of a third-party service. So imagine that, let's take the example from before. So earlier we demonstrated how we monkey patch the get item property of the local storage to make sure that no one has access to it. But the problem is that this functionality only applies to the top main realm of the application. But that doesn't apply automatically to a child realm, for example. And if the child realm is in the same region as the top main realm, they share the same local storage. So I can basically create a new iframe, access its global object, and then access its local storage, and then access the secret item from the local storage. And you'd see here that effectively I gain access to the item that I was trying to protect in the top main realm. That is because the functionality, the protection functionality that I apply to the top main realm does not apply automatically to iframes and same origin realms. Now, the second example that I'm worried about is how an iframe can manipulate the top main realm using the functionality from within based on the fact that the inner functionality was not overridden by the third-party service. So let's examine that as well. This is a new example. In this example, you can see that we want in our application to include a trusted payment service. So it's a service that I made up that I implement in my application as a third-party iframe. And with that iframe, I can charge my clients for payment services. I want to make sure that no one changes the source of this iframe. I want to make sure that the source is the service that I'm working with. So I can override the behavior of the iframe prototype to make sure that if anyone tries to change the source of the iframe, they will see an error instead. So you can see in this example, so when I try to create an iframe and then redirect it to the fake payment service instead of the real one, my behavioral override makes sure to not allow that, and it throws an error. But there's a problem with this solution. That won't work because I can easily create a new iframe and then steal the HTML iframe element prototype from within it and then use the prototype of the inner realm to change the source of the iframe that I'm trying to protect. And you can see here in the example that it actually works. The error is no longer being thrown, and I am successfully changing the SRC of the protected iframe. So that is an example of how I can take a same origin iframe and use its unprotected functionality to manipulate maliciously the top main realm of the application. So now that we understand these two problems, we can grasp the fact that this effectively leaves realms out of reach for both security and for both visibility third-party vendors. So whatever they try to apply, it won't automatically apply to same origin realms, and attackers that manage to run code from within the application would be able to to mess around with the security mechanism that we're trying to apply. So that makes the same origin realms to me as kind of a blank spot that we should find a way to fight against. Now, I hope that laying out the problem as we did so far clarifies what the needed solution is. We need a way to dynamically and automatically apply our security logic or our visibility logic to all child realms within the application rather than only the top main realm. Let's talk about that a little bit more. So if we being able to just apply our security mechanism automatically to realms, the examples that we talked about earlier would not have been relevant, right? We're gonna do so for same origin realms only, because cross-origin realms are irrelevant because they are not a security threat to the top main realm because they do not have synchronous access to it. So we're not too worried about cross-origin realms. We need a solution that allows us to apply our dynamic logic to all same origin realms as the top main realm. And that kind of makes sense if you think about it, because that is a power that already exists. You have that power for extensions. So an extension can ask the browser to execute the content script in every new realm that comes to life within the application. The only difference is that extensions have the ability to execute code within same origin realms and cross-origin realms as well. We don't want that power. We want that power from the same origin realm, from the top main realm, only to apply it to same origin realms. And I think that's only fair. I think that if you have your own application and you want to be able to control it, you should have synchronous control to all same origin realms that rise up within your application. I think that only makes sense. In my opinion, that would make a hell of a browser native API. But since we don't have that, the only way to implement that is using the concept of JavaScript shim. So we can implement a JavaScript library that when you apply it at the beginning of the application, exposes that API that we're imagining. But that is a hard task to accomplish for two main reasons. So first of all, in order to successfully apply it in terms of security, we need to cover every possible way of creating a new same origin realm. And we need to make sure that we monkey patch the ways to do it. And not only that we need to be aware of every possible way to achieve that, we need to make sure that we synchronously apply any dynamic logic to the new same origin realm. Because if that doesn't take place synchronously, it means that an attacker can create a realm and then abuse it and only then allow us to take care of it. So we need to make sure that we take care of it before an attacker has any access to it, and which makes it very complicated as well. And this brings me to the main topic of this talk, which is the solution that we're working on called Snow.js. So meet Snow. Snow is exactly that. It's a JavaScript shim. Snow stands for Securing Nested Ownership of Windows. We're using the term Windows rather than realms because this is a browser-oriented solution. It is irrelevant to JavaScript in general. It is specifically relevant to browser, and the global object that we're trying to protect in browser is called window.
Gal, can you explain again what is a JavaScript shim? Because I think I missed it.
Yeah. So a JavaScript shim it's just a general concept in the JavaScript community where you can create a sort of a library that applies a certain logic to your runtime application, and that way exposes a certain API that you expect the language or the browser to expose in general. So for example, so you can think of polyfills, for example, for certain stuff. There are also they're sort of shims because a shim also allows you to think of a suggestion to a JavaScript, like a proposal to JavaScript API that you want maybe to introduce through TC39 committee. So before passing those proposals on to actually shipping them into JavaScript, sometimes you just want to create a shim that allows us to see how that proposal will behave once it'll be built into the browser or JavaScript. So that is the concept of JavaScript shim. And we are trying to achieve that here with Snow.js as well, because we do believe that there is a certain logic behind trying to have it as a browser built-in API. But since that is a long way to go, we first implement Snow.js as a JavaScript shim. I'm going to talk about it too. So Snow.js is the library that is behaving as a JavaScript shim to solve the problem that we talked about today. It has the simplest API. It's just get a callback, and it makes sure to pass that callback every new realm that comes to life. It makes sure to remain as synchronous as possible for the security reasons that we talked about. And it covers a big amount of ways to form same origin realms, which is the main challenge in this project, I think. Ideally, we'd like to cover all of them, which is the main goal of this project, but I learned the hard way that this is insanely difficult. You have just so many ways to create same origin realms. Snow already works smoothly on Safari, Firefox, and every Chromium-based browser. It also smoothly works on the biggest websites you know. So it was tested on Facebook, Instagram, Google, TikTok, all of those guys. It is heavily tested specifically against security breaches, which is the main goal here. And let's talk real quick about how we actually consume Snow. So you can implement it using the classic npm or yarn install. You can also include it as the first script in your application, and it'll just automatically apply the shim, and it will expose the new API that you consume as part of this application. The API is called Snow. And then just as simple as that, you just pass a call back to Snow, and every time a new realm is created within the application, that global object of that realm is passed on to the callback that you provided. So let's talk about how it works exactly. So Snow also leverages the concept of monkey patches because in order to remain synchronous and to capture realms synchronously, you have to use monkey patching. So there are just so many ways to create same origin realms. You can do so by creating iframe nodes and inserting them to DOM. You can achieve that by injecting HTML string to DOM. That is also something that Snow has to cover. You can achieve that by opening new tabs. So new tabs are also same origin realms by default, unless you redirect them to a cross origin. Redirection of already attached to DOM realms is also a problem, because that's also something that Snow has to cover in an entirely different technique. Nested realms is also something that Snow has to cover as well. And I think one of the most interesting concepts here is the secure JavaScript aspect. So implementing Snow is not enough. Sorry. Hooking into all the possible ways of creating a realm is not enough. You need to make sure that the JavaScript code of Snow is also as secure as possible, because if anyone manages to monkey patch a function that you use within Snow, they can basically maliciously abuse what Snow is trying to achieve, and that could also result in a bypass of Snow. So you need to make sure that the functionalities that you use within Snow are unforgeable, and that is also a challenge. I'm gonna demonstrate everything in a demo, but I first want to basically connect all the dots. This is the moment. I want to show you how Snow serve us. So we had two problems that we talked about before. The first one is how same origin realms can go under the radar of third-party services behavioral overrides. So let's see how Snow helps us here. So this is the same example as before. You can see in the bottom line that by attaching an iframe to the document, I can bypass the local storage protection mechanism that I applied before. This is the same example as before. But you can see here that by simply passing the protection logic to Snow, Snow will make sure to apply that protection logic not only to the top main realm, but dynamically to every new realm that comes to life within the application, which effectively results, so you can see here in the bottom line, this effectively allows us to apply that logic to the iframe that we earlier used to bypass the security mechanism around local storage. And you can see here that this time when we're trying to access the secret item via an iframe, we once again are being rejected because the logic, the security logic that we usually apply to the application is shipped automatically to all same origin realms using Snow. And the second example that we talked about is how realms can also climb outside of themselves to the top main realm and affect those. So that's something that Snow helps us with as well. So once again, this is the same example as before. This is the trustedpaymentservice.com example when we make sure that no one has the ability to change the source of the iframe to anything malicious. And being the same example as before, you can see down below that we successfully bypassed the security mechanism and changed the SRC of the iframe by leveraging a new iframe. But with Snow, you can automatically ship that logic to every new realm, and by that, no one would be able to change the SRC of the iframe, even if they steal a prototype of the HTML iframe element from another realm. So this is effectively the power of Snow, and it is relevant to every security vendor and every visibility vendor that is trying to apply a security mechanism to the top main realm of the client-side runtime application. So this is Snow. Let's talk about the current state of Snow. So Snow is actually actively being used. Snow is used to protect MetaMask. I'll try to keep this short, even though it's a bit complicated. But to make long story short, in MetaMask, we work on really interesting JavaScript security related stuff, and we also have a different security library called LavaMoat. So LavaMoat is just like any other security vendor. It applies a certain security mechanism to the application, and by that we achieve enhanced security to the MetaMask browser extension. But the problem is that we don't have an ability to ship that logic to all realms within the MetaMask extension. But thanks to Snow, we can just take LavaMoat and just apply it to all same origin realms in the application. So if anyone manages to break into MetaMask and execute code, and they want to avoid the security mechanisms that LavaMoat applies to the extension, they can no longer create a same origin realm and abuse it to achieve that, because Snow would make sure that LavaMoat applies to all iframes in the application. There are a lot of things that we still need to do with Snow. So the security aspect of Snow is really complicated. There's just so many ways to create a same origin realm, and we're trying to cover all of them. Hopefully that we'll be able to accomplish that. The adoption of snow is something that I want to improve. So far MetaMask uses snow, but I think it's going to be really relevant to like a lot of other vendors, hopefully. Vendors of security and visibility, both. We're also trying to convince people that this should be a built-in API in the browser, because I truly believe that applications should have power over the same origin realms that are being created within their runtime. I think it's only fair. And that's pretty much it. I think before wrapping up, I would like to show you like a quick demo of how Snow actually functions. Hopefully it'll work. So oh, right. I forgot to log into. Thank you.
I don't know yet. Don't thank me yet.
So
Yeah.
Snow being such a simple API solution, and it's really, there are just so many interesting, simple ways to like demonstrate Snow. So I created this application. It is strictly client-side oriented. There is no backend to it because we're talking about client-side technology here. So this application uses Snow to eliminate the alert function. So you can see that the alert function is being overeaten by another function that I created. So if I try to alert one, instead I get a message to the console. Now, the reason that this application is interesting is because this is basically a challenge. And your challenge is to successfully pop an alert in the context of this application. And you can do whatever you want. You can create new realms. You can think of any way that you know to pop an alert. And hopefully you're not going to be able to do it. Luckily, I have been, there are people who already found vulnerabilities in Snow using this demo, and we also fixed them. So this is like a really fun journey. But you can see here that the default example can demonstrate how. So for example, you can see in this function that I'm trying to, let's zoom in so it'll make a bit more sense. You can see in this example that I am trying to create a new iframe and then use the alert function from within that iframe. But that's not going to work. You can see here that it is being thrown to the console instead.
Even the cross-origin iframes?
That's an excellent question. Thank you for asking that.
Next slide.
Yeah. So no, that's an excellent question, because as I was trying to explain in the conversation here, is that Snow is only relevant to same origin realms, right? Because we are not worried about third-party realms, because they cannot synchronously access our application and they cannot manipulate it or abuse it.
Right.
So I'm not worried about third-party origin realms, and therefore Snow, whenever it detects the realm to be cross-origin, it just leaves it alone.
Right, but in this example, the alert will work, right?
Yeah.
Or
yeah.
So it will work.
Yeah. If you create a cross-origin realm and then you use it to alert, it's going to work.
Okay.
The challenge here is not only to pop an alert. The challenge here is to call that alert on the top main realm window. So you can see that using HTML is not going to work either. There are a number of ways to create a load event, and they are not going to work either. This example is actually outdated because we have since found very complicated ways to create same origin realms. But all of those that we are aware of to this point are covered by Snow. I invite you to go on this application and demonstrate your ability to pop an alert on the top main realm. I would be thrilled to find more vulnerabilities in Snow and to fix them, because I really want to achieve a secure state for this project. And I think a lot of entities this would be beneficial to a lot of entities. And hopefully that makes sense right at the end.
It's okay. There's no, it's not allowed to show off the show.
I think I do want to show the last slide, but let's try here. Maybe it's because I connected to Wi-Fi.
No.
Because I had
No, I don't think it makes
Can you
it.
refresh it, the page?
Let's see. Because I activated the
Offline.
offline option.
Technology, it's terrible.
Let's try with that real quick.
No, but now with the refresh, you're doomed.
I'm fucked.
Yeah.
All right, let's do it like this.
Yeah, the best way.
Yeah, so thanks for having me. My name is, here are like a couple of really like the important links for this conversation. So you can check out my blog post. I have a lot of security related stuff, specifically in terms of JavaScript security. There's a link to Snow.js. There's a link to the Lava Mode project that Snow is a part of, which is a really interesting JavaScript security project. Check out MetaMask, and also you can check out Consensus. So Consensus is the company that is the parent company of MetaMask, which I'm part of. Yeah, that's pretty much it.
Cool.
Thank you so
Thank you very
much.
much.
Interesting. I want to ask if you think is it possible to just disable the creation of new realms if I want to, like, so nobody can create iframes if I control the code.
That's a good question. So without Snow, the answer would be no. But you can use Snow to capture every new realm, and then with the code that you provide to Snow, you can just eliminate that realm. You can just remove it from DOM. But without Snow, as far as I'm aware, it would be very hard to prevent it from creating new realms.
I would probably need to disable to override the property of.
But that wouldn't be enough. Even if you write the property, if for example you override the property, but then you inject an HTML representing an iframe to the DOM, the DOM is going to parse it even though you override the property, because it doesn't go through that override.
Okay.
Also, you can, even if you override DOM related stuff, you can also create a new tab, and a new tab is also a semi-region. Anything that has like friction with DOM makes it insanely hard to just like change behavior completely. By the way, that is also why Snow is a really complicated project. Having so much friction with the DOM makes it really hard to cover all possible ways to create a new semi-region realm. I want to believe that we are very close to cover as close as possible to all of them. But every time I think that, someone finds a vulnerability. So it's a tricky one.
Cool.
Yeah.
We have questions in the chat, right?
Yeah, let's go over the chat. I know that the guy answered some of them, but yeah, let's go over it. So we cannot see the slides. Dan, can monkey patching also affect the app performance? Galia Geber from your friend.
Sorry, I see the confirm. Confirm is a different function. We're talking about specifically alert in the demo.
Can monkey patching also affect the app performance dramatically when trying to find security issues in runtime?
Oh yeah, that is a fair question. Yes, the answer is yes. That is something that I've been doing monkey patching for most of my career. So at the beginning, I not only harmed the security and the performance of the application, I also was privileged enough to break Fiverr completely one time.
Nice.
Because monkey patching is a dangerous technique that you need to be very proficient of. Otherwise, you can ruin the application in like so many ways, including performance. But I do believe that if you're well aware of what you're doing in your monkey patches, you can achieve a smooth state. And I invite you to take Snow and inject it to any application that you use. I have a technique for testing Snow. So I inject Snow to every website that I visit, including in my personal life. And if Snow breaks something, then I'm not allowed to use that application until I fix Snow. So I was not able to watch Netflix on my Mac for like a few days just because Snow broke it. But
A Chrome
now,
extension. You mean the Chrome extension, right? Of Snow.
so Snow is a shim that runs within the application itself, but I use an extension to inject Snow
Right. That's
to the
what I meant.
application.
Yeah. Okay.
So now you can use, so Snow works smoothly with YouTube, with Netflix, with Facebook, with Instagram, with TikTok, you name it. If you can find something that Snow breaks, I would love to be aware of it. I promise to fix it, but the answer is yes. You need to be very careful monkey patching stuff.
Wait, but for Snow to work, it needs like when you show the API, you need to set the callback function and to actually use Snow API.
Yeah, so what I do,
So, yeah.
okay, so if you're gonna use if you're gonna pass Snow a complicated logic,
Yeah.
then to me, that's on you. That's on the
Yeah.
consumer of Snow.
Mm-hmm.
I only make sure that the monkey patches that Snow applies are cool. So what I do usually, I just console log, hey, there's a new realm. When I use
But what I'm asking is like, do you pass like a basic callback function to Snow, or how do you test it? That's what you do?
That's what I do. I pass
Okay,
it
cool.
a callback that just console logs every time there's a new realm.
Oh, okay.
Yeah.
Cool. Okay. Okay, so why can't malicious code monkey patch security monkey patches?
Perfect question. If you allow any JavaScript code to run before Snow, then that JavaScript code can breach Snow for sure. So if you want to use Snow and you want to remain secure, Snow has to be the first JavaScript code that is being executed within the application. If it does, Snow makes sure to apply its monkey patches in a monkey patchable way, because when you redefine properties using monkey patching, you can ask the ecosystem to no longer allow redefinition again. So when I apply a monkey patch using Snow, I also ask the browser to not allow behavioral changing again. So that technique would not be applied. The only way to achieve that is if you run before Snow. And I cannot guarantee to protect your application if you don't execute Snow as first script.
Wait, but
A
when
script
you
or a bundle, or is it bundled? Can it be bundled into?
So you can bundle it, but you need to be very aware of how your bundle is being constructed, because you might, like Snow might not be the first script if you use a bundle.
But also script is
usually bundles using closures that runs after other functions.
yeah.
It's problematic.
Yeah. So, but are you worried about third-party scripts?
No, I'm just worried that I won't be able to run any code before Snow is downloaded and executed, and then I can only run any other code
That's
of my
true.
application. If it's bundled, it's immediately. But you said there's more problems. Yeah.
But if it's
more
bundled, that
complicated.
means that you also you also download the bundle from somewhere. It's just like you do save one download. I agree.
Yeah.
Yeah, that's a pitfall for sure.
Right.
and also like you said that you guaranteed that there will be no later monkey patching, but what if it's relevant for other vendors like Sentry, for example, and stuff like that, right? Like they say I do need to
Right.
monkey patch this method, so
Yeah,
why
exactly.
choose this?
Yeah, so it's not one or the other. What I expect vendors like Sentry is to use Snow. So what I expect them to do is to leave their logic as is, but instead of like just applying it to the top main realm, use Snow to monkey patch everything. So I imagine you take Sentry and you just pass it as a callback to Snow, and then what happens is that Snow just applies the monkey patches of Sentry to all of the realms that Snow protects. So that's what I expect to happen. They're supposed to work together. They're not supposed to work one against each other.
No, I understand, but like, let's say that you say I want to monkey patch the alert method as we saw before, right? And let's say that later on I also want to monkey patch it and do something else, but I will probably still run the alert that you monkey patched already. So I don't have access to, I will not be able to alert Voldemort, let's say.
Yeah.
Okay, right? You still protect it at that point, but why not allow someone else to also protect it? And like, let's not say LeBron James is the greatest player of all times.
Yeah.
Something, you know what I mean?
Yeah, that's actually a good question, and that reminds me. that what I said a few minutes earlier was wrong. It was the case for Snow before, but when I understood that this is a problem, we changed something about Snow. So let me make that clear.
Yeah.
Snow no longer applies monkey patches in a way that are not redefinable. And the only reason that I have this privilege is because I apply those redefinable patches to all realms. So if anyone wants to change the behavior of something that I monkey patched, I allow them to do so because of the fact that if they are going to monkey patch it and then use the native functionality in their patch, I am that native functionality.
Yeah,
Right.
the vulnerability is already patched. It's
Exactly.
already fixed. So
Yeah,
that's why I'm saying like there's no reason to
That's a
prevent
fair
them.
point, and that is the
Okay.
correct answer. What I said
Okay.
before was wrong.
Okay, cool. So a lot of info from Guy. I'm gonna skip unless you think some of it is relevant, just not to read all of it. A shim is a piece of code used to correct the behavior of code. Oh, I think it's just somebody answering. Differs from polyfill, which implements a new API. Okay. And that's it. Yeah, cool.
What do you think? What do you think about there are other ways to try to protect third-party code by now there's a new way that you probably know Partytown.
Yeah.
So they have. I'm just wondering what you think about it because it's just another way to try to protect third-party code by running them in like service worker, and then you have the ability to know which APIs they're calling because they provide the callback of the API. What do you think about it? Have you tried it, and have you seen like some the pros
It's a
and
fun
cons of it?
question. I think Partytown is an amazing project, honestly. I remember first seeing it, I was like, this is so cool. I sent it over to the guy. It's a cool project. I think, by the way, originally, and I think that's still the case, it was not created as a security project.
Right.
It was created to like
right.
load balance. Yeah.
Performance, yeah.
But it does act as a security mechanism, which is great. But I think what's interesting about Partytown is that it allows you to maintain security against the different dependencies and third-party services that you contain within your application. I think that if you combine, for example, Partytown and Snow, then you just get two different layers of security. But I think in terms of like using Partytown for security, sounds like a really interesting project. I haven't tested it myself, but it's a really interesting thing. I do appreciate what they do there.
Yeah. Yeah, we do try to use it for third-party code right now. They provide a handler. We're still researching it, but hopefully it will work.
Yeah, maybe consider Snow if it's any relevancy. I would love to discuss it.
Cool.